Hello, and today we'll be talking about exercise physiology and the adaptations that the body makes during long-term exercise. And we're firstly gonna have a slight introduction. So I'll introduce you to the two different types of respiration. Now, if we look at an anaerobic activity such as sprinting, like 100 meter, for example, as you can see in the top left-hand corner. Um, a sport like that or an activity like that would be usually a short duration but very high intensity, and that means that it requires lots of power and speed at a rapid pace, and it also needs high ATP and PC stores. So you need to be able to um, exert as much ATP and PC and phosphocreatine as possible in a short period of time. So it's so that you can remain at maximum speed for longer. That's why these athletes would do certain things such as interval training, and it will also help to improve other things that we'll go into later, such as cardiac output, stroke volume, cardiac hypertrophy, those kind of stuff. Now, if you look at an aerobic activity, such as like cycling in the bottom left, you can see that there are quite a few physical demands of this as well. Of course, this is the complete opposite to the anaerobic one, because it's a long duration but a low intensity. And you definitely need, for this one, you need a lot more of cardiovascular endurance, muscular endurance, and muscular endurance. And a lot of elite athletes will require large cardiac output, and the heart will go through hypertrophy a lot more as well. These cyclists would normally have to help try to increase their lactate tolerance, and also have a higher lactate acid threshold so that it would cause delay OBLA, so it will not be, the OBLA will be delayed. It also, so these athletes now are different, slightly different. They would do more training such as swimming, circuit training, or fartlek, or even a phosphodiesterase cycle, which is kind of like an interval training because of the different speeds they may be going at. Now, there are two other pictures on this slide, and as you can see, there are two events that, well, the javelin, with the exception to the javelin, which is an anaerobic activity, the taekwondo match, this will be varying levels. So at some points, you'll be expected to perform anaerobically and aerobically. Now, if we're going to look at aerobic training methods, this one is for those who mainly want to improve their power, speed, strength, and those kind of things. So if you look at the interval training, this type of training will have alternating periods of high and low intensity intervals. So they may jog for a bit, then they sprint and jog for a bit. This is why this is continuous. So this is kind of similar to continuous training, but it does push the body aerobically and helps to improve that cardiovascular endurance and muscular endurance. Now, continuous training is quite similar. Interval training tends to be cycling or running, but continuous training can be also like weightlifting or um, the same. It could be running or cycling as well. And this is where where the performer will do an exercise for a long period of time and like continuously, with shorter rest periods, um, and may probably lower resistance. And this would help to improve their muscular endurance specifically and mainly. There's also the fartlek training, which is quite similar to interval training, and this works to push the body. This is normally on different terrain or just to push the body in a different way so that it can improve its aerobic processes. Cross training is also useful. This is like for total body. Um, this is also working on muscular endurance, and making sure that the body can perform for as long as possible. Rock climbers would use this, for example. Now, athletes that are doing these programs would usually do these probably 3 to 4 times a week, to get maximum results. And they also would probably they would be all working at quite a high intensity, because a lot of them are intermittent, such as the interval training, the firelight training, where you have bursts of energy, like quick bursts of energy. And the cross training is quite intense as well. The continuous one's probably the lowest of intensities. Um, Normally sessions for this kind of stuff, because it's such high intensity, the periods would be shorter, so maybe half an hour to 45-minute sessions. And also, when a personal trainer is dealing with an athlete, they have to make the program to suit and make sure they don't go through tedium also. Now we're going to look at anaerobic training methods and look at 4 different types of training that the anaerobic athletes would normally use. So the first one is HIIT training, and that consists of exercises that would kill literally put the muscles into distress so that they can repair themselves and get bigger. These are usually very high in intensity and very short in time as well. And the sessions are not that long. They're usually probably half an hour long, and they really make your muscles burn because of their rep range is quite high, and which makes the activity even more intense. The other type of training is plyometrics, and as you can see in the picture, it consists of quick movements such as jumping to improve those muscle fibers and muscle spindle, to be able to produce explosive power. So that would improve your explosiveness and your reaction time. Those kind of stuff would help. For the HIIT training, that's mainly to improve muscular endurance, muscular strength, and those particular things that you would need in events such as sprinting. The speed and agility training, that's kind of similar to circuit training, and it improves exactly what it says, your speed and agility. These are very high in intensity, as like all of these are, and don't go for very long. And then resistance training is mainly to improve your muscle mass, your muscle strength, and muscular endurance. Not so much muscular endurance because we are doing anaerobic, so it would normally be strength, so be muscular strength, and these would be quite high resistance and low rep range. Now we're going to move on to cardiovascular adaptations, and in the cardiovascular system, certain adaptations have to occur after doing exercise for long periods of time or training quite often. This tends to be, so it will, because of these, so these things will occur that you see on these bullet points will occur. So stuff such as cardiac hypertrophy, athlete's heart, lower resting heart rate, lower working heart rate, cardiac heart output, capillarization, hemoglobin levels, and also blood viscosity would have to adapt. So this normally would happen over, let's say, a period of 6 weeks for an athlete. So firstly, cardiac hypertrophy is a process which increases the size of a muscle, well, in particular for this cardiovascular system, the heart muscle. It thickens the walls, the myocardium, so that stroke volume or cardiac output can totally go up. So when this occurs, because the muscle walls are bigger and stronger, it means that the contractions can also be stronger and more blood can be pumped out the heart. And if more blood can be pumped out the heart, that means that the heart would need to pump less. So hence the reason why when we're resting, your resting heart rate would be lower. And if you do, if your heart rate does get lower, you can have something called athlete's heart, which is basically heart bradycardia, and it's normally when your heart is enlarged and your resting heart rate is lower than 60 BPM. So that's the definition of bradycardia as well. That's when your resting heart rate is below 60 BPM. Now, when you're working as well, when you are exercising, your heart rate will be lower because it can pump blood more efficiently. So if you had the same work, let's say an athlete had the same workload as a regular person, the athlete could be working at the same level, but their heart rate would still be lower because more blood can be pumped out the heart more efficiently. This also leads to an increase in cardiac output because more blood can be pumped out the heart regularly. For capillarization, this will occur more rapidly and more frequently, and it will cause quicker diffusion, and so blood getting into the bloodstream. I mean, oxygen getting in the bloodstream. So more oxygen will get in the bloodstream, and then more CO2 will also be put out the heart as well, put out the body as well. Sorry, um, and then stuff like blood volume as well. These characteristics, the plasma that carries the carbon dioxide will also increase. So more CO2 is leaving and exiting the body. Um, and also the blood viscosity gets a lot thinner, which means that the blood cells can move around the body more quickly to get to working muscles. Also, the blood is these cardiac adaptations can also reduce chances of certain cardiovascular diseases, such as arteriosclerosis and or arteriosclerosis as well, and also hypertension. This is because the heart works more efficiently, so it does mean that it will be less likely to get these certain diseases. Um, and also, performance wise, if athletes do get these adaptations, for example, sprinters, if they were to be able to increase their cardiac hypertrophy, this means that they would be able to have athlete's heart and they would be able to sprint quite quickly because blood get around the body quite fast, although they don't really need that much oxygen. But especially for the long distance athletes, for long distance runners, um, the resting heart rate, the working heart rate, cardiac output, capillarization, blood viscosity, these are very important because the body needs to get oxygen to the muscles as efficiently as possible, and this is how those cardiac adaptations do occur. Now, if we take a look at a VO2max test heart rate data, this is before exercise and after exercise. We can see that before exercise, which is the top line, before you start your 6 week period, you notice that it starts out on the heart rate profile graph. It starts around 139 BPM, and again it goes up quite steadily. But after your 6 week period, you can see that it has decreased almost 20, at least 20 BPM, and that means that he's working at this. He's doing the same amount of exercise, and he can work for longer at a lower heart rate as well. That is partly because of these CV adaptations. The similar graph is shown on the right. Now we're going to move on to respiratory adaptations, and here we'll talk about the increase in ventilation, breathing rate, and submaximal activity, the adaptation of the respiratory muscles, the lung volumes, and also capillarization and gaseous exchange. Now, in cycling, for example, higher lung volume is needed to increase ventilation, thus increasing tidal volume, and of course, ventilation will help CO2 to get out and oxygen also to get in to the lungs. If these things can be increased, that helps a lot because lung volume will increase, tidal volume will reach its maximum. Also, the breathing rate will also decrease as well. Yeah, decrease as well because you'll be able to take more oxygen in and push more carbon dioxide out. Now, respiratory muscles get stronger because because as your respiratory muscles get stronger, your oxygen deficit um, and and you're